Hi, this is Synthchaser from synthchaser.com. In the previous video, we rebuilt the voice boards of the Oberheim OB-8. We changed about 80 components on the voice boards to improve stability and reliability and the tuning of them. Now we've actually got to go through and calibrate these. So in this video, I'm going to show you how to calibrate an Oberheim OB-8. So I finished up with the voice boards and I put them back in. In order to get them back in, you have to remove the right end cap, and there's 4 screws on the bottom that you remove, and then you can get them in. This will also allow you to adjust the voice boards, the lower voice board, by folding the upper one up like this. Otherwise these panning pots can't clear the case. So I did repair the Oscillator 2 that was bad. So see, I've got only Oscillator 2 is on now, and I'll cycle through the voices. That one was the bad one. And now it's oscillating just fine. The problem turned out to be an unusual one. It was this polystyrene capacitor that's used in the circuit with the Curtis chip. It tests okay out of circuit, but at a certain frequency or range of frequencies, it was shorting out. So I repaired that, and we have all oscillators firing. And now, if we try the auto tune, it's going to cycle through all the voices. And it succeeds. So previously this voice number 5 would be removed from the rotation because the oscillator was bad. Even though auto-tune is working, we did change a bunch of trimmers, and the keyboard's due for a calibration, so I'm going to show you how to do that now. So while I had calibrated the power supply previously, now that everything is finished and reconnected, I'm just going to verify the power supply voltages. There's only 2 rails that adjust. The -5 rail here is sitting at -5.007, which is as good as we're going to get it. And you can measure it here on the control board. There's some little terminals that you can use to test. So I'll move over and check the plus 15 volt rail is sitting at 14.99, which is also about as good as you can get it. So power rails are okay. Power supply doesn't need any further calibration. So now we're ready to calibrate the OB-8, and calibrating an OB-8 is a lot easier than calibrating an OB-XA or OB-X. They put some thought into it and designed a calibration procedure that's integrated with the synthesizer, so it's not relying on you measuring various waveforms on oscilloscopes and stuff like that. So the way that we put this into calibration mode is turn this test 1 switch that's under the hood here up, and then we can begin calibrating. The first thing that we're going to calibrate is the DAC, the digital to analog converter. This is what takes a digital input, ones and zeros from the microprocessor, and spits out a voltage that's used often as control voltages or offset voltages to the analog circuitry on the voice boards. So it's very important that this is calibrated correctly, otherwise things won't scale as you go up in octaves. So because the DAC calibration is so important to the performance of the keyboard, we're going to want to use a good multimeter. Precise multimeter. We'll leave the free Harbor Freight multimeter out of this one. So you want to use one like I've got there, or a system multimeter like this that can produce is accurate up to 6.5 digits of resolution. And we've already turned the switch to test 1 on. So now we'll turn the keyboard on, and the first calibration that comes up, because it's the first thing that you do after the power supply, is the DAC calibration. And you can actually switch through the different calibration routines with these buttons here. So the first one that's lit up here, Oscillator 1 mod button, that's for the DAC. So I'll turn my multimeter on, and I'll put it into high res mode. And there's 2 adjustments that you can make to the DAC, and the trimmers and connection points are here. So you connect your red lead of your multimeter to the DAC out, and the common lead to the analog, to the ground, analog ground. And there's two trimmers, the offset and the scale. So what the DAC does is it takes a binary number from the CPU and converts it to an analog voltage. And it can spit out voltages between 0 and 10 volts. So the DAC offset is used to zero this out. So we're going to press this low C, and it's going to feed a 0 into the DAC. And you can use this to adjust any offset to get this perfectly at 0 volts. And they are single turn trimmers, so there's going to be a limit to how precise you can get it without replacing the trimmer. This is sitting right now at negative 0.2 millivolts. So that's very accurate, and that's so we don't need to adjust that. The next adjustment that you can make is to this next trimmer, which is the Dac Scale Trimmer. So we're going to hit the next key up, which is the D, and it's going to send the highest possible number into the DAC, so all ones, and it should spit out a 10 volt voltage. And this is 9.997 volts, again, as good as we can get it with the single turn trimmers that are in there. So the DAC is calibrated well on this already, so we don't need to make any adjustments here. But if you did, you would just adjust these two trimmers and then go verify that both of these are still correct when you're done with your adjustments. So we're going to advance to the next calibration, which is the bender assembly. There's two trimmers here which control the offset of the pitch and modulation levers. So they're off when they're resting in the center position. And so to advance to this calibration routine, we hit Oscillator 2 down here, and this lower light will show up. And then we can pick which lever we're going to be calibrating by selecting the key here. So this is for the left lever, this is for the right lever. And I mentioned that they made it much easier to calibrate these OB-8s than previous Oberheims. We don't need to measure any voltages. The microprocessor will actually check and tell us whether the trimmer is calibrated. So there's these two LEDs up here, and if one of them is lit, only one of them is lit, then it's not in calibration, and you need to tweak the trimmer until you get both LEDs on. When both LEDs are on, the microprocessor says that this is calibrated. So I hit the C key, and this lever is, you can see as I move it, it believes that there's an offset, and then I need to calibrate it. But when it's in the middle, both LEDs are on. And then I'll hit the D key, and this lever is also in calibration. Again, as I move it off the center, it thinks that there needs to be an offset added to center it. But when it's resting in the center, this is calibrated. So the next thing we're going to check is if the envelope offsets need to be calibrated. And calibrating them depends on which revision of the ROM you have, and there's a procedure. You can either press page 2 in a certain combination to find out what version of software ROMs you have. But the easiest thing, since you're working on this anyway, is just to open it up, and they usually have a sticker on there. This is revision A8 of the ROM. Earlier revision ROMs, if you need to calibrate the envelope offsets, you're in a lot of trouble, because you gotta actually replace op amps until you find the right one that you need. But what we're going to do is we're going to look to see if even the envelope offsets need to be adjusted. And to do that, so I've got it on manual, I've got Oscillator 2 on, and what I've done is I've changed the envelopes here, both the filter envelope and the volume envelope, to high attack and everything else at minimum. And what we're going to do is we're going to cycle through the 8 voices, and we're going to listen to see if there's a difference in a significant difference in the amount of time it takes us to hear the note. And to me, they sound pretty similar. The service manual says you're looking for a greater than 2-second difference between that. And these are all very close, so we don't need to adjust the envelope offsets here. So the next thing we're going to be doing is adjusting the oscillator volts per octave trimmer. These are the multi-turn trimmers that we just put in as part of the voice board kit. So I've switched the test one switch back on, so it shows that we're in the Dac calibration mode. We did this one, the bender assembly. We're going to move to the next one, which is calibrating the volts per octave of oscillator 1. So now the keys down here control which voice we're going to be adjusting. So let's start with voice 8. So hit this this C, and now the LED, the gate LED for voice 8 turns on. And again, we're using these two LEDs here to see if the microprocessor thinks we're calibrated sufficiently. So here, only one of the LEDs is lit up, so we're not calibrated properly. So we're going to adjust this multi-turn trimmer until we get it calibrated. So there we go. And if I go a little bit further, now it's too far this way. So this calibration is made a lot easier with the multi-turn trimmers that we put in. So now I'm going to go to voice 7. And we're good. Voice 6 is calibrated. Voice 5. There we go. Voice 4, so we're just going to bend this up. It's on a hinge, so we can get to the lower board when we're doing this. So here's 4. So 4 needs to go a little bit the other way. There we go. 3. Two. And 1. Fold this back down. And now that's all there was to it. We've calibrated oscillator 1 on all the voice cards. So now I'm going to hit the next button here on the bender assembly, this bend amount, and we're now moving to calibrate the volts per octave of oscillator 2. So again, I'll start up here, and so the trimmer for oscillator 2 is another one that we replaced with the multi-turn. So that's calibrated. Voice 7, calibrated. 6 is good. 5, this was our dead oscillator before. And now it's calibrated. Let's move down to voice 4. Done. 3 is good. 2 and 1. There we go. That's so much easier than the other OB series synthesizers to calibrate. One last thing we need to calibrate for each oscillator is the F envelope. So that's one of these trimmers, this trimmer number 2. Which we didn't replace. So we'll start up here on voice 8. Again, very simple process. Little touchier on the ones that we didn't replace with the multi-turn trimmers. You can see it's kind of flickering there. But there I've got 2 stable LEDs now. Again, you can replace all of the trimmers with the multi-turn, and that will allow you to get a better calibration and have an easier job of it. But this was still workable. So I'm going to adjust the next voice there. This one's close, but see, it's flickering a little bit. But I barely touch it and the other one starts flickering. Now I've got it fairly solid on both LEDs. There we go. We'll move down to the lower voices. Piece of cake. And if you've seen my other videos where I do this on the OBXA, you know, you need an oscilloscope and all that stuff, and it takes a long time. Piece of cake here. So the next thing we're going to do is a couple of built-in tests for the LEDs and switches that they built into this calibration routine. So we're skipping the transpose up and moving up here to the mode button. And when we push that, all the LEDs light up, and that is this test, and there's nothing else to it. So if there's any LEDs out, then you know you have a switch that you need to replace. The next one is the switch test, so we're going to press this arpeggiate button, and now we can go through and push each switch and see that the light turns on, which means that the switch is working. So if you have any intermittent switches, you can find them here and replace them. And the way that you test the auto-tune switch, which doesn't have an LED, is you watch the Oscillator 2 detune light, and that'll turn on when you press that switch. So the next test we're going to do is the oscillator drift test, and this one will initiate by hitting this upper button here, and the upper button is flashing now and showing that the test is in progress. And what it does is it waits 10 minutes to make sure that everything is temperature stable, and then it auto-tunes the voices, and then it waits another 10 minutes and then compares the frequency for each oscillator to make sure that it hasn't drifted. And if any of the oscillators do drift, it's going to let us know by lighting up one of the buttons up here. So we'll know when this test is over because this light will go solid, but it's going to take about 20 minutes and then we'll check back on it. So 20 minutes later I'm back, and the upper light here is now solid, meaning that the drift test has completed. And you look here at this row of buttons, and if any of them have an LED lit, that means that a corresponding oscillator has drifted more than an acceptable amount and needs to be looked into. Fortunately, all the lights are off here, so we're good to go there. So now we've taken it about as far as we can with the built-in calibration routines. I know there's two buttons, transpose up and the lower button here, that we didn't use, but they don't actually correspond to any calibration routine. So there are a couple more calibrations that we're going to need to make or verify, and we're going to have to do that manually. So we're going to go ahead and turn the test 1 switch off to put it back into normal operation mode. And we're going to be taking a look at the voice board filters and the volume level for the two voice boards. The next thing we're going to be calibrating is the filter and resonance for each of the 8 voices. So to do that, dial up this patch. You have all the light, you have it manual mode, all the lights turned off except the keyboard tracking, all the knobs turned fully down with the exception of resonance and the volume sustain. And you get a patch that sounds like this. Not very loud. In fact, it should be pretty silent. So what we're going to do is we're going to calibrate each voice individually, and in order to turn on and off the voices here, we go to the page 2 menu, so hitting that chord page 2 button twice, and now these 8 LEDs are lit up, and this lets us disable or enable voices. So right now all 8 voices are enabled, and I'm going to turn off all but number 8. And you can see now when I press a key, the gate LED for voice 8 is the only one that lights up. So the way that we calibrate the filter is first we go over to the 2-pole resonance filter, which is number 4, 404, 304, 204, etc. And we'll turn this and just until we get, I'm pressing and holding middle C. I'm going to turn it just until we get some sound. There we go. So now we have, we can hear something to calibrate. And then the next thing that we adjust are the VCF offset or frequency and the VCF volts per octave. So the way we're going to do that is we're going to hit C, and we're going to get this this tuned to C. And it can be challenging with the single turn trimmers. Now we're going to go up an octave, and that's not quite a C. So what we're going to do is we're going to adjust the volts per octave a little bit in the opposite direction, actually, to make it sound a little bit lower. Now we're going to go back to C and adjust this initial frequency back to C. Now we'll try the next C again, and we're pretty much there. So we'll make sure that this scales, and we've calibrated the filter there. Now we're going to hit this middle C again, and we're going to back the resonance trimmer off until it's quiet, and then we close the hood and we move to the next voice, and we repeat this for all 8 voices. So not far into this at voice number 7, the second one I'm doing, I found one that I can't calibrate. I'm pressing the note and you hear it drifting quite significantly. So what I'm going to do is I'm going to change the 2 trimmers. It's possible that there's some damage to those trimmers that are causing this this noise basically on the calibration of this filter chip. So I changed out these 2 trimmers, the VCF frequency and the VCF volts per octave, and now I have a nice stable filter, and it's scaling, and I could calibrate it a whole lot easier with the multi-turn trimmers rather than the original trimmers that were there. So this is another reason why you might consider just replacing all the trimmers instead of just the volts per octave for the oscillators. So I'm going to repeat this process now with the remaining 6 voices, and then we'll wrap up the filter calibration. So I finished calibrating the filter for all 8 voices, and I wound up having to replace the trimmers on 2 more, so three voices total needed a change of trimmers in order to get the filter tuned and stable. So filter's good now, and the last adjustment that you may need to make is the volume, the Vca adjustment. So the Vca trimmer is right here, and there's one for each voice board. And what you do is you turn both of them up all the way, and then play notes and cycle through the voice boards. And if you notice that the voices on one of the board are louder than the other board, then the one that's too loud, you just adjust the volume down. And that, in a nutshell, is calibrating the OB-8. So I'm going to close this up now by putting the side panel back on, by screwing the remaining screws down to the voice board, which I was flipping open and closed, and by closing up the screws to the top of the case, and then I'll show you the final product. I closed it up, and now we'll turn it on, and we'll hit auto tune, and it's going to cycle through all 8 voices. This was the one that was failing before, so we're going to watch for flashing LED there, and all the LEDs stay off. So we've repaired the oscillator, all the voices can auto-tune, and we're ready to give it a try. All the voices sound consistent from voice to voice. I took unison off here so I could cycle through the individual voices. And I'll give you a little sampling of the sounds of this keyboard. Here's a good one. It's a unison with all the voices on, and the oscillator's detuned. Very big sound. Sounds like a CS80 there. I like that one. So as you can see, the OB-8 is a very expressive instrument, and you can get a lot of good sounds out of it. And I'm glad that we brought this one back to good health and repaired its dead oscillator and rebuilt the power supply and the voice cards. So it'll be ready to go for another 35 years. I do sell the kits that I use, the voice board kits and the power supply kits, on my website, synthchaser.com. And if you have any questions about the OB-8 or any other vintage synthesizer, please post in the comments or contact me through my website. This is Synthchaser from synthchaser.com. Thanks for watching, and have a great day.